Hi folks. So today we will be discussing about Unit 2 design examples using programmable logic devices and finite state machines. First, let me know about the memory hierarchy. It starts from lower order down top approach. It is nothing but bottom up approach from magnetic tape, which is offline storage, magnetic disk, main memory, cache memory, and registers. So from the register to the main memory, which is in board memory, magnetic disk, which is detached away, so it is an outboard storage memory. Register is nothing but a storage device which is basically made up of flip-flop which stores one bit of information, either 0 or 1. Whereas the other devices like magnetic tape, magnetic disk, which are away from the processor and is detached from the microprocessor. Semiconductor memory classification: volatile and non-volatile memory. Volatile: when the power is off, the data goes off. Non-volatile: when the power is off, the data remains as such. Volatile as SRAM, DRAM, static random access memory, and dynamic random access memory. Non-volatile as read-only memory, flash. Read-only memory as PROM, EEPROM, E-square PROM, flash as NOR and NAND implementation. RAM, random access memory, accessing the data from the memory randomly, hence we state this as random access memory. So here it's a schematic representation where we have a select line, we have a read complement signal, and we have a D flip-flop with a clock signal in order to enable it, and we have input output data. Whereas a transistor with a capacitor is called as dynamic random access memory. Address line is connected to the gate of the transistor, bit line at one end of the transistor. At the other end, we have a storage capacitor which we require periodically refreshment when a capacitor is present connected to the ground. And so physical appearance of RAM, SRAM looks like this, and the DRAM physically looks in this way. The memory chip organization: we have write signal, chip select signal, address line from A0 to AM-1, data line from D0 to DW-1, and it is in a form of array with lot of words, which is nothing but the address line word 0 to word 3, and we have a decoder. So 2 input, 4 output, 2 is to 4 decoder with a chip select signal and write signal, and we have a configuration of a specific cell of a 4x4 RAM. So we have D0 to D3 4 datas, Q0 to Q3 4 bit of information, 2 address line A0 A1, and the output write and chip select. So this is a 64 word cross 1 bit to DRAM. So here we will be having a array format in which we have 3 address line A0, A1, A2 connected to the row decoder, A3, A4, A5 which is connected to the column decoder, and a specific cell, one particular cell is being enhanced. How it stores 1 bit of information, which is nothing but array RAM, which we discussed earlier, and constructing large RAM from small RAMs. So with the help of two 4x4 and the cache memory. So cache memory, we have different levels of cache: level 1, level 2, level 3, which is present in between main memory and the register file of CPU. And we have the last memory as secondary memory. And we have a physical look of hard disk drive that rotates per minute at a speed of 5400 and 7200 rotation per minute speed. And here we have a schematic representation how to the address line from A0 to AK-1 is being selected, and we have a select lines S0, so embeds at the top, and we have different words are nothing but the address, and it provides input and the output bits. So here It's a form of construction. So row decoder selects specific row, and that will be getting inside your word, which is nothing but the address, and the drivers is used to amplify swing rail to rail amplitude. Column decoder, it provides an appropriate word to be selected. The purpose of the memory is used to store the bit of information without any loss. Thank you.